simply tremendous.
That's the bottom half of Block 6 in the approach and retreat monitoring.
We're trying to stay with.
Okay, Ricky, copy that. Go for step 3 of procedure 1.110.
So they just gave them a go for the setup for capture. And this means that the crew is going to go over all the things that they, wanted to make sure the robotic arm, the cameras are pointing at the right place, and that they're also just reviewing their what if this happens, cue cards, making sure that they're both on the same page. I like this view here where you actually see now what used to be just a little dot is now looking like a real supply ship. It's barrel-shaped with the solar array wings. And then that grapple pin is right on the very front, on the very top there. You can see in the bottom right-hand corner the numbers. It says 30 there, and that is 30 meters away, about 100 feet away. And they're so close that the crew can look out the window and know, that the Cygnus is in a reasonable place. And that's why they've put away the radar gun, because we don't need that confirmation of the mathematics and of all the systems.
The team here confirming that Cygnus has initiated its final approach, so this is where it'll move from 30 meters up to 10 meters, and that'll be the final hold point, the capture point.
7 and 1.102. The crew is primed to send retreat if primary range is less than 6 meters.
Okay, I understand we're primed for retreat, and the prime range is within 6 meters.
And so the crew and the ground were just agreeing on something they both already knew, but we make sure we're really thinking the same thing at the same time, and that is that if they see on their screen that Cygnus is closer than 6 meters, about 20 feet away, then they will hit the retreat button and make it move one step back, which would be to the 30-meter point. So when Paolo and I did this, we captured HTV-2, and it was the second time a free flyer had been captured from the space station. Now, from the shuttle program, we're kind of used to, going up, meeting the Hubble Space Telescope, grabbing it, putting it in the payload bay, repairing it. And it's different on the space station because if during that capture for the Hubble, it didn't look right or things were just going crazy, then that shuttle commander could move the space shuttle away.
Yeah.
But that's what's not possible with the space station. I mean, it's a giant, huge, it's like, moving, a giant factory compared to moving a school bus.
Right.
It's really a huge thing, and so we can't move the space station. So that just makes the capture operation that much more critical. And everything on the ground has to be more precise, and the crew has to be more precise as well. So I will tell you that, one of the ways that I make sure I'm not nervous is that I know that I've done all the practicing and preparing, and that's what the crew's been doing over the past week or so, is doing a series of rehearsals using virtual reality simulations on board to think about what if this happens, how am I going to feel, what if this happens. Something that came up that was a little unexpected for Paolo and I was that when the arm is moving into that to grab that spaceship, the Earth was moving in the background. And it was very distracting, and it made it harder to really understand what the distance was.
Yeah.
Is it now 3 feet away? Is it 2 feet? Is it 2 feet or is it 5 feet? That's a big difference when you're getting close.
Do you ever actually get, and this is probably an odd question, but do you ever actually get nervous doing these kind of things?
I think that's an individual thing.
Yeah.
I don't think you can afford to be distracted because you're nervous, but certainly you're pretty focused. I was nervous,
Yeah.
definitely. And, because we were a little distracted by the distance, I had started on in, meaning the end effector is moving towards the HTV in my case, moving towards the HTV. And like anything, when you're a little nervous, you might do it a little fast.
Yeah.
And I looked down and I saw the rate that I was going. I'm like, oh no! And so I slowed down, just as Paolo was saying, "Hey," and so I think everybody on the ground was probably saying, "Hey," as well. So I started it a little faster, slowed down. This is a great picture right here where you see the Cygnus hovering. It's about 90 feet from the station, and it's going to come in to about 30 feet from the station,
yeah.
and
that's about 15 feet from the arm, and then
Houston station on 2 for the block Bravo reporting. The white tracking light is within the corridor on both monitors. Vehicle size matches the vehicle outline on both monitors, and
so the crew was talking there, and we have what we call as handover when we go from one satellite to the other, where we don't have comm for about 30 seconds or so. So we'll catch them on the other side. So this is a graphical representation of what you were seeing out the window. So you can see in the upper left is the Cygnus, and then the arm is sort of reaching out there. In the lower left there, what looks like a kind of a strange landscape. This is what the camera that is on top of the end effector is seeing, and right now it's seeing nothing, right? Because the Cygnus is not moved into position.
Yeah.
But when the Cygnus is in position, you're actually going to see the target on the Cygnus, and the target is made up of basically a T-shaped graphic, okay, with a pin sticking out of the middle of the T. And if you're either sort of above the T or below the T, you're actually going to see that pin sticking out, making another line on your T.
Mm-hmm.
And that's one of the tools that we use to see how far away we are. The other thing we use is a second camera looking at it from the side view, so we can measure closer and closer and closer.
Yeah.
Cygnus approach.
Go ahead.
Yeah, Ricky, the trend on the block Bravo monitoring remains the same, but looking at the camera 03 S1 lower outboard, the aft white track light is about a quarter width, port side with respect to the circle. And on the monitor 3, camera 09, it's right at the center, so there's a little difference between the two monitors.
Okay, Koichi, we're comfortable with that. You're go to proceed.
Okay, copy that.
So Josh, they're saying that we've got several cameras pointed at the Cygnus, and each of them should show that the Cygnus thinks it's exactly in the same box, but one of them is just a little bit to the left, basically.
Yeah.
And the reason for that is that when we say camera, please point yourself at say 47 degrees, it's 47 plus or minus. A little, and that's what leads to the difference in their visual picture. And MCC was saying, hey, we see that and we're comfortable. We think the Cygnus is at the right place.
So again, we're at 14.5 meters. It's going to go up to 10, and that's where it will hold. We'll have another go, no-go, and then that should be the capture point coming up in about 18 minutes, give or take a few. Everything proceeding pretty much according to the timeline, if not just slightly ahead, which of course is good news.
So Josh, looking at the graphic here, we can see the Cygnus coming into place. So it's come in from 30 meters, and it's on its way to 15 or to 10 meters. Okay, so 30 feet, and so you see it slowly inching closer, 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 and I'm looking at the view on the bottom left there, where you're seeing over the mouth of the end effector. You're looking at the camera view, and you see the gold sort of blob there on the bottom.
Yeah.
That is the actual grapple pin, which is about a foot or so long. I mean, it's huge.
Yeah,
I mean, the grapple fixture is about as big as, like, if you chopped me in half, that's how big the grapple fixture is. But right on top of it, the black line, that is the target that the camera is looking at. And you can see that it's gradually approaching the middle of the screen. If you look in the upper left, you're going to see the Cygnus is now looking at, like, it's right at the level of the robotic arm. And you see that same picture in some different views. These are graphics that are simulating what we are sure that the cameras are seeing on board. Now, unfortunately, we are not going to see the actual video right when they capture because we don't have that satellite in play.
Yeah.
But we'll see a replay, right?
Well, hopefully, if the crew sends us some video. Yeah, that's we hate to be the bearers of bad news, but that is always how things work out. Sometimes we don't have video coverage. So if we don't, at the point that they do it, then we'll show you this view here, and we'll be able to confirm that it happens. But of course, we always like to see things, and sometimes it doesn't work out that way.
You know, so down here on the ground, you know, we see, so to speak, our vision is partly just using some math and some engineering. And so this graphic here is not just a cartoon, but it's actually based on data that we are getting from the Cygnus, data that we are getting from the space station about where the Cygnus is. We've got data on where the robotic arm is. As soon as those joints start to move, even though we don't have a visual picture, we have a data picture, and it's going to show the joints moving, the arm stretching out, and so you're going to understand. We transfer that into a visual picture so that we have a feel for what the arm looks like as well.
Houston Station on 2 in step 8 of 1.102. Capture conditions are confirmed, and the crew is ready for Cygnus capture.
Houston copies. Stand by for go for capture.
Standing by.
So even though we're about 15 minutes away, the team here is go for capture. Yeah, Flight Director Brian Smith here notifying the orbital flight director that the station is ready to accept the vehicle. The crew is ready for their next steps.
Station Houston on 2. You are go for Cygnus capture sequence. Step 4 in 1.110, the approach and monitoring and capture.
Copy that. Go for step 4 of 1.110.
So Josh, this is it. This is the actual capture. They've given them a go, and then it's just a question of how long it takes the crew to carefully go through their steps. And so they're putting the arm into mode. They're making sure that it's in the correct configuration. They're arming the end effector. You don't want that trigger to be hot, you know, the whole time you're up in the cupola getting ready. You want it only to be hot right now. And so the ground is confirming that they're seeing the arm gradually get into the correct configuration for capture. And then we'll actually see, even though we've only got our graphic there, you will actually see what the arm is doing using this graphic, and it's going to come closer and closer and closer to our target there on the bottom left.
And right now the space station is exiting the eastern coast of Africa. Looks like its altitude about 260 miles. So capture should be taking place right over the Indian Ocean if everything goes according to plan.
When we captured the HTV, I was particularly proud of having us be right over New England. I felt personally responsible.